is often linked to negativity among many people. It can be a traumatic experience, and for whatever reason, people tie mathematics to intelligence. They think if you can do math, then you're smart. If you can't do math, then you're not smart. According to statistics from the Carnegie Foundation, about 50% of all US students go to two-year colleges. Of those students that go to the two-year colleges, over half of them have to take remedial math courses, which are essentially the exact same courses that they took in high school, but they don't get any credit for them in those two-year colleges. About 10% of those students are actually able to pass those remedial math courses, while the remaining 90% are forced to drop out because they simply cannot pass those courses. Based on this data, what do you think is the top reason for this? Is there just too many math standards for the students to learn? Do students just not have the ability? Are teachers to blame? Is math just not for everyone? I believe the math content is not the problem, nor is it the students, but rather the way that the mathematics is commonly taught in the US. Math involves logic, reasoning, critical thinking, and tenacity. These are all things that people absolutely love to do. Give a riddle to a person and you'll find that many times the people love trying to solve them. Sudoku puzzles enthrall people for hours. The same can be said of board games, video games, etc. The human mind loves thinking, reasoning, and figuring things out. Some of the main problems with mathematics is that it's not taught this way. It's not viewed as a riddle to be solved, and oftentimes math problems are not explained in a way that allows students to thoroughly understand what they're even looking for and why it is important. Other times math is shown as a series of steps to be memorized and followed rather than understood and applied to new situations. The critical thinking skills needed when learning mathematics are real-world 21st century skills that students will need regardless of what they do after high school. Many students believe that they dislike math because they will never need a particular algorithm or equation outside of school. This is mostly true, but the skills of reasoning and critical thinking that should be the focus of math courses will always be needed. So if you were asked what's the best way to teach math, what would you say? Well, a colleague of mine asked me that very question, and this video is going to be representing my response to how I would teach math. A good place to start might be what a good math teacher is not. Math teachers should not be math tellers. Rather than challenge students to build their own understanding of concepts, tellers tell students exactly how they're supposed to be understanding the concepts. You may be a math teller if you tend to show students how to solve a problem, do a couple of examples of that exact same problem, and then expect students to basically just repeat that same process on an assessment with different numbers. Being a math teller is almost like giving the students a puzzle that's already solved rather than having them put the pieces together themselves. This brings up a fundamental issue with understanding what good teaching consists of. Most students, parents, and even other teachers think that if you explain concepts in a clear, concise way, then you are being a good teacher, when actually you're just being a good teller. The problem with telling is that students are not being challenged to think mathematically. In essence, the teller is doing all the thinking for the students. The students are more focused on becoming good at calculations instead of mathematical thinking. Please note, this is not to say that teachers should not be helping students, but helping students is not the same thing as showing them how to do a problem. Many teachers admit to becoming a teacher because they want to help students and make things easier to understand for them. This notion of making things easier to understand goes against what research has showed us as the best way to possibly teach. Research has identified one of the most important things that teachers do to affect student conceptual understanding. That is to make sure that students engage in what is called a productive struggle. That means they are producing some kind of understanding of whatever the concepts are through a struggle of trying to figure out how that concept works. This involves not just telling students something that can be made easier, but instead focuses on providing students with challenges that contain clear instructions and providing enough time to figure things out. Probably the biggest role of a teacher is to promote 21st century skills, create excitement, and build students' confidence toward learning and thinking. None of this is promoted if teachers are simply the medium in which students get easier explanations of concepts. Another attribute of what a good math teacher does not look like includes teaching students exactly how to do a certain type of problem and then giving them that same problem over and over again with different numbers. This type of rote basic skills learning can be done by a simple computer. The last thing we need is students thinking and acting like a computer. There needs to be a human element to the learning, an aspect of discovering new concepts collaboratively, making mistakes, debating answers, attempting problems that are completely novel, etc. If a simple computer can do it, then students probably should not be. Doing calculations is not the same thing as doing math. Unfortunately, most assessments are simply assessing calculations while ignoring the concepts. One of the biggest gripes that I have about tests like the ACT is that they are timed and more focused on calculations than actual thinking. Math, among the other subjects the ACT assesses, is meant to be deeply thought about. Instead, students learn how to take the test. This gaming of the system does not provide any in-depth thinking beyond the test itself. Assessments in math class should not follow the ACT's lead. It is much more beneficial to have concentrated thinking about problems rather than students robotically completing problems as fast as they can in order to finish a test. If a concept is important enough to be tested on, then it is important enough to be given the appropriate amount of time to be thought about. As a society, we do not need speedy executors of process anymore. Calculations can be done with computers. We need mathematical modelers, predictors, justifiers, communicators, and problem solvers. We need more people that program and work with computers than people that act like them. These type of people are what make up the future STEM jobs. The heart of math is to deeply understand concepts and how they are related to each other in order to solve other problems. This type of thinking is the basis of intelligence, and time should not limit this. With the ubiquity of information due to the advancements of technology, memorizing facts, formulas, and equations has become more and more obsolete. Valuable learning time should be spent on working on higher order thinking rather than rote memorization. Too much math instruction is centered on students as passive absorbers of knowledge rather than active understanding seekers who create, alter, and integrate knowledge. So now let's talk about what good math teaching looks like. Learning math can promote cognitive strengths that cannot be found in any other discipline. The kinds of thinking that I'm talking about involve logic and reasoning. In this type of learning, numbers take a back seat to the thinking. However, such thinking is not part of most curriculum. Instead, we get an unsteady collection of seemingly unconnected skills and procedures, which many teachers proclaim to have to reteach every year as if students had never learned them before. Time and time again, research has shown that most students who are considered to be good at math under the traditional math setting often cannot apply a single thing they have learned in a novel setting. As math teachers, we tend to focus on what to teach rather than how to teach. This makes math class more like a checklist of processes and algorithms for students to memorize rather than mathematical thinking. So what needs to change? Well, first, I believe we need to inform students on how learning actually works. As discussed previously, I believe a teacher's role is to inspire students to not only think, but also to want to think. In my opinion, too many students think they hate math. In reality, they hate what they think is math. A better way of describing what they hate is more like they hate memorized mathematical procedures. This makes sense if you know anything about control theory. People tend to focus more on what is controlling their learning rather than the learning itself. For example, if you are rewarding students with points or a grade for their learning, they tend to focus more on the points and the grade rather than the learning. I tell students this on the first day. I explain them the psychological ideas behind a lot of the teaching and how it can affect them. That way they might be more likely to be informed enough to attempt learning in a different, more productive way that focuses on intrinsic motivation. Provide clear instructions. Oftentimes students are not confused about the mathematics. They are confused about the setup of the class or the instructions of a lesson or what they're trying to solve for, or sometimes even just the way a website is set up by a teacher. The biggest confusion in class should be from the mathematics, not the learning environment. When giving students a challenge, have them repeat back the instructions that you just gave in order to make sure that they actually understand what you're looking for. Ditch the in-class lecture and focus on self-paced learning. Self-paced learning provides students time to create their own understanding of the material. Lecturing to an entire class assumes that all students are at the same place in terms of their understanding of the content. Videos are a great alternative to lecturing and provide an excellent medium for students to utilize self-pacing of learning. They're able to learn at their own pace, pause, rewatch, and ask questions about specific parts of the video to the teacher or their peers. Most students in a math class are there because they should be based on their ability. With the exception of a few incorrectly scheduled students, most should be able to complete the majority of the necessary concepts in the class. Oftentimes, concepts that they struggle with in the beginning make sense toward the end of the course, allowing them to catch up to the rest of their peers. Also, mastering all units in a course, except for a few, is much more valuable than kind of understanding all of them. Be inspiring and informative with feedback. Some students come to class finding math simple while others find it difficult. However, this does not reflect their potential for future understanding. Students have been gaining different experiences since childhood. Some of those experiences cause synapses to fire and others do not. As teachers, we need to change the path for those students that never had those synapses. Students need an environment that is personally challenging. Neuroscience shows that every student has the ability to excel in math. The potential of the brain to grow is huge, huge, and despite the belief in fixed math ability, every learning experience can change your math capabilities. Fixed ability language should be used as least as possible. This includes saying things like, "You're so smart," "You're so good at math," or "You really struggle with math," etc. While it might seem nice to tell students positive fixed ability comments, research shows that once students do something that is perceived as not smart, they tend to not believe the fixed ability comments that they received from their peers or their teacher. Instead, the focus should be on effort and actionable feedback. When giving feedback, make sure students know that you are critiquing them because you believe in their ability and potential to succeed. Starting any feedback to a student with a positive statement makes feedback even more powerful. Just make sure to praise what students have done rather than their intelligence. Focus on students actively creating their own understanding. What makes a great math student? Is it that they have a toolbox of memorized procedures at their disposal to solve contrived problems? Or is it they can figure out how to solve a novel, authentic problem based on what they previously learned? While many teachers might say that the second type is more ideal, most teachers still teach based on that first way. This produces students that know how to solve a problem, but not the mathematical ideas behind it. This does not help when applying that approach to solving a new problem. How something works is vitally important, but the further applications of a concept become more extended when one understands the why. The problem that most teachers face is that the why does not come immediately for most students. As teachers, time is always against us, so rather than spending time on understanding the why, teachers give students the easiest way by telling them what to do. Students memorize this process from the teacher and use it to solve problems that they do not fully understand. Once the test is completed based on those skills that were learned, the process is completely forgotten about by students, forcing them to re-memorize it for a more complex math class on top of the learning that they're already getting from that new math class as well. This repeats over and over until the students finish all the required math classes. They learned how to solve these problems without knowing why or how they work. The procedures were learned, but then were forgotten easily, and since they were never really fully understood, they're never actually connected to any of the new concepts that we covered. This is part of the reason why mathematics may seem fragmented instead of a connected web of concepts. This is not to say that students do not need to know how to do basic skills. What I recommend is instead of telling the students, have them discover it on their own through activities and problem-solving exercises. Having students use past understanding of concepts to help them learn how to solve new problems helps tie old concepts to the new. This provides a deeper understanding for the students. It is important to note that not all students can discover concepts on their own. This is where the teacher comes in. By providing hints, you urge students to understand concepts, but by challenging themselves at their own pace. This provides for deeper learning as well as a habitual way of solving problems that promotes understanding instead of just remembering. Students should not dispel a concept until they fully understand both the how and the why. Students should be assessed on both of these understandings to ensure full comprehension of the concepts. As research shows, students who participate in informal quantitative reasoning are able to complete formal math assessments with much greater ease. Similarly, students who are asked to give reasons for their thinking are better at using logic to explain an argument. Research has shown that when math is taught with a focus on problem-solving skills, logical reasoning, multiple forms of representation of concepts, and question formulation, students perform at higher levels, take more advanced math classes, and equitable achievement is created. When these aspects of math are promoted in class, students' intelligence and ideas are more valued, which leads to higher confidence in math. Simply put, if you don't ask students to think, they won't. So don't tell students the steps to take. Have them create their own steps to take, and then they should be able to explain each step along the way. Teachers should be facilitating this type of thinking and giving hints along the way when needed. It is vitally important that teachers not lose the big idea of students actively creating their own understanding and making connections of what they are learning. Lesson plans should include higher level thinking questions that are novel in their approach and perspective. A sign that you're doing things this way is that when students say things like, "We haven't seen this before," that's good because that's how they can build their own understanding of how to solve those problems. Breaking that habit of students only solving problems that they've seen can be time consuming at first, but it comes back tenfold toward the end of the course when students are working more deeply and independently on solving problems such as these. Differentiate. Confidence is a huge factor in doing well in math. Students need to be completing problems at their level and finding success. When helping individual students, try not to have predetermined questions. Instead, think about the student's current understanding. Listen to their ideas and try to create interesting questions that relate directly to their ideas to push their limit of their current understanding. Avoid routines in questioning and the construction of student problems. If you want students thinking outside the box, they must be challenged accordingly. There needs to be well thought out strategies for each student. Their prior knowledge, confidence level, and motivation all need to be taken into account. Make sure students are making mistakes when learning, not on summative assessments. Recent brain research shows the value of students working on challenging work and even making mistakes. However, many students are afraid of making mistakes and think it means that they are not a math person. If mistakes are designed into the learning process rather than the grading process, students will look to them as a way of learning rather than as an assessment of their abilities. Research shows that mistakes cause more synapses in the brain as well as more growth. Provide feedback not just from the teacher. Feedback also needs to come from multiple sources, including peers, teachers, experts online, and most importantly, themselves. Peer-to-peer feedback has been shown to increase student understanding in both the students giving feedback as well as the students receiving feedback. As Grant Wiggins famously said, learners need endless feedback more than they need endless teaching. So as teachers, how do we get there? Well, first of all, don't think all or nothing. Don't think you have to change an entire course to match the style of math teaching described. Chances are you're probably already doing a lot of what I described. If you simply make small changes and proceed to add more and more throughout the years, you will have a course that focuses on mathematical best practices. You can choose to modify a unit in a year or maybe even one lesson a week. Like learning, teaching in new ways requires a self-paced timing for teachers as well. Comfort level and the learning curve for teaching in the prescribed way are different for each teacher. Make sure you have backup. Make sure you have a support system in place to help you. I'm lucky enough to have an administrator that supports the way I teach and allows me to come to him if I ever need help or any other ideas. Other teachers, even in other subjects, can also be a great source of support as well. Make mistakes and don't be afraid to make those mistakes. Often teachers avoid the possibility of making any mistakes. As a professional, we must get over such discomforts for the sake of our students. So in conclusion, teaching math this way is rewarding, exhausting, but completely necessary. The world is changing more now than it ever has. We need logical thinkers, creators, modelers of abstract ideas and concepts. Mathematics provides an excellent way of promoting those skills. We as teachers just need to make sure we teach it that way.